For the first week of class, we learned one new equation. We used it quite a lot for pretty much a full week of class. That was v is equal to delta d over delta t. This stands for the constant or average velocity that's experienced by something when the velocity isn't changing. We call that our group A equation now, because it applies in our group A situation, that situation where we're not accelerating, where we're not changing speed, where we're going at a constant speed. But we now have some group B equations as well. Some group B equations that are used whenever we have something that's speeding up or slowing down. In other words, when we have an acceleration. You remember that an acceleration is the rate of change of velocity. The rate of change of velocity, meaning that the base equation for acceleration will be delta v over delta t. The rate of change of velocity, rate, time on the bottom, change of velocity, delta v on the top. That's our first equation. And we're allowed to use that whenever we have an object that's accelerating. Doesn't mean it's always going to fit, but we're allowed to try it at least. We also have four other ones that we're allowed to try whenever we have an acceleration. Vf squared is equal to vi squared plus 2ad. We have delta d is equal to vi plus vf over 2 times t. And then, of course, we also have d is equal to vit plus 1/2 at squared. Don't expect you to memorize these. You got these on your data sheet. You can use your data sheet for a quiz or for a test. You also have d is equal to vft minus 1/2 at squared. So whenever you have that situation where it's constant velocity, use group A. Whenever you have that situation where you have an acceleration, speeding up or slowing down, let's use group B. And just write down your givens and see which one seems to fit the best. We had a couple questions that we were working on a couple of days ago before we did our activity on page 48. I want to take a quick look at those questions, and then we'll do another example here, okay? Let's try question number 2 here and see how that goes for us before we look at our next example. It says the ball moves up a hill with an initial velocity of 3 meters per second. 4 seconds later, it's moving down the hill at 9 meters per second. What's the displacement of the ball from its initial point of release? Something's 3.0 meters per second. Something is 9.0 meters per second. And something is 4.0 seconds. What is this 3 meters per second thing? What is it? Good, it's VI. It's the initial velocity of this ball. Good. What is this, 9 meters per second? Yep. Good, it's final velocity. What is this, 4.0 seconds? That's the easy one, right? 4.0 seconds is the time interval that's elapsed, and we're looking for the displacement of the ball. Now, I don't know if any of you are thinking right now, there's a mistake there. Maybe you are. Maybe you're just afraid to say it right now in case you're wrong, but you're not if you're thinking that. There is a mistake there. Anybody spot what it is? Jordan? Yeah, we got to make that -9. Okay, strictly speaking, it doesn't really matter whether we define up the hill as positive and down as negative, which we just did, or the other way around. Up could be negative and down could be positive. I think it makes the most sense to do it this way. So that's what we'll do. All right, we got those 5 equations. This is group B, clearly it's accelerating, slowing down as it reaches the top of the hill and then stops, and then it speeds up as it starts going back down the hill. Just a question for you, actually, before we look at which equation to use. Cover up those answers there. Would you expect your displacement there to be positive or negative? That's a tricky question, actually. Would you expect your displacement to be positive or negative? Yeah? Why? Okay, Patty? No, it's a good guess, but no. If I had, let me give you a little hint here. If my final velocity, oh, you got an answer for me? Yes. Yes, that's exactly it. Good. If my final velocity was -1, then that would mean that at the end of the problem, I'd be on my way down the hill at 1 meter per second. But it would mean that I didn't reach my initial point because I'm not going as fast as I started. I'm going -9 down the hill. That's way more than 3. right? That means I've gone more down than I went up, right? Does that make sense? So we should expect to get a negative value here. Let's see what it is. I think I want to try d is equal to vi plus vf over 2 times t. But if you happen to try another one, that's okay. Probably end up coming back to this one at some point. 3 plus negative 9 divided by 2 times the time of 4.0 seconds. So 3 plus negative 9 is neg 6, neg 3. Neg 3 times 4 is neg 12 meters. So, yeah, our displacement is negative. It means we're further down the hill than where we started, which is to be expected given that we're moving faster down the hill than we were up the hill when we started. Good. Let's try this example. On page 50 here, it says a golf ball that is initially traveling at 25 hits a sand trap and slows down with an acceleration of neg 20. You got to be careful with this. They tell us that the acceleration is negative 20, but they don't really have to tell us that. They could just say that it slows down with an acceleration of 20. If we think about that and read between the lines, we should be able to determine that it's a negative value because it's slowing down. What's the displacement after 2 seconds? Is it stopping? Doesn't say that, does it? So we can't assume that it does. Maybe it does, but certainly can't assume that. Let's say VI is equal to 25 meters per second. We're going to say that A is negative 20 meters per second squared. And we're going to say that the time interval here is 2.0 seconds. I'm looking for the displacement. What do you want to try? It's group B. Can't use V equals D over T. Which group B equation do you want to try? Jen, you got one there? Just take a look at your data sheet, guys. Okay, everybody should be looking right now. Your data sheet, see if you can find one that fits. Jen's going to give me one. It may not be the one that I'm looking for right now, but she's going to give me one, and we're going to try it. Okay? You know what? I think that one's going to work for us. So I think you cut to the chase and went directly to the one that is the most efficient one. We have VI. It's 25 meters per second. Delta T is 2 plus 1/2 of negative 20 times 2 squared. So sure enough, we've got all the variables in there except the one that we're solving for. 25 times 2 is 50 plus 2 squared is 4 times 20 is 80 times 1/2 is 40, but it's negative because of the negative 20. 50 plus negative 40 is 10 meters. So how far does this golf ball go in the sand trap? 10 meters. Let's try those 2 questions, please. Let's write down some givens for question number 2 now. We're going to say the motorcycle is traveling at 100 kilometers per hour. Its VI is 100 kilometers per hour. We're going to convert that to meters per second by multiplying by 1,000, dividing by 3,600. Gives me 27.7778 meters per second. Let's go, since it's not a final answer, 4 or 5 decimal places. Okay, let's round it only to a decimal place or whatever when we need to for significant figures purposes. Okay, let's say VI is this. Let's say the time interval is 1 minute. I want to convert that to seconds, so I'm going to say it's 60 seconds. Don't go converting that to hours because you're in kilometers per hour initially. Like, now is not the time to start saying, oh, you know what, I can be in whatever units I want as long as I'm consistent. That was the case with our group A equation. Whatever units you want as long as you're consistent. Here, you got to be in seconds. You got to be in meters. You got to be in meters per second. Okay, my acceleration is 0.80 meters per second squared, and I'm looking for my displacement here, delta D. Is that right? Kyle, what's wrong? Right there? Yeah, good. We got to have a negative acceleration here, right? Because we're slowing down. This, if you're moving to the right and they want the motorcycle to slow down, then the force and therefore the acceleration has to be to the left. It has to be opposite to the way that's moving. If the acceleration is in the same direction as it's moving, what's going to happen? It's not going to slow down. It's going to speed up. All right, let's look at what equation seems to fit here. One of our group B's, probably this one. Let's give it a try at least. 27.7778 squared, no, not squared, times 60 plus 1/2 of negative 0.8. How many people made the mistake there and made a positive 0.8? Oh, two of you? Seriously? I guarantee it was more than two of you. If I was in grade 11, if I was doing physics 20 for the first time, I probably would have made that mistake. Such an easy mistake to make, right? Especially at this point when you're only a couple weeks in. Lots of people are going to make that mistake. We just want to learn from that mistake and hopefully not make it again, at least when it counts. All right, let's calculate this as a group now. 27.7778 times 60. Let's add to that. Let's put everything in that second term in brackets. Add to that 0.5 times negative 0.8 times 60. Let's square it. And this is what we end up with. 2242 or 2.2242 should be 2.2 times 10 to the 3, right? Anybody else get that, or did I make a mistake? Oh, I did. It's amazing how close that came, though, actually. Yeah, you're right. I did square everything. I should have squared just the 60, right? So let's try that again. Let's say 1666 0.5 times negative 0.8 times 60. Let's square just the 60 this time. So the square goes inside the brackets. Oh, you know what? I didn't have it remarkably close. I was 2.2 times 10 to the 3. The answer should be 2.3 times 10 to the 2. 2.2 times 10 to the 3, 2200 versus 230. Is that okay? Yep. How to get this? Follow on the calculator here. We said, yeah. Oh, okay. I see what you mean. You mean the rounding part of it. Okay, fair enough. We've talked a little bit about significant figures, but we also said don't worry about significant figures too much right now. Tomorrow we're going to have a little practice quiz on this stuff, and then Friday we're going to have a real quiz on this stuff. If you make a mistake on the significant figures and you just make that 226 on Friday's quiz, I won't take marks off for that. Okay, but I do want you to learn significant figures because eventually it's going to start counting for us. If we look back to our original data, this is 3 digits, this is 2 digits, this is 2 digits. That means my final answer should have 2 digits. My final answer was 226. I don't want to make that 220, just drop the 6. I don't even want to make it 2.2 times 10 to the 2. I got to go to my second digit here. Since I'm rounding to 2 digits, I got to go to my second digit and then look at the third digit and say, is it greater than 5? It is, so that rounds up. So it becomes 2, just stick a decimal point in there, 3. Number, decimal, number, times 10 to the, well, I had to move the decimal over twice to get from 226 to 2.3, so it's 2.3 times 10 to the 2. Does that make sense? Show you a little trick as well on your calculator, okay? I shouldn't show you this, but it's really, we should be able to get to that point, right? But let's say we get an answer of 226.668, and you're like, I'm just not very good at putting it in scientific notation like that. I know I need to put it in 2 digits, and the only way to get it in 2 digits is scientific notation. So what's a neat little trick on my calculator to do that? Go to mode, scroll over there to scientific, and then just times your answer, what you just got, by 1. Because that should give me 226 again, right? Except this time it's going to give it to me in scientific notation, which is 2.26. Well, I want it 2 digits, so 2.3 times 10 to the 2. Make sense? That becomes a little bit more useful when you've got a number that's like 0.000000494, right? So you don't have to count that many decimal places. When you're talking about 2 decimal places, that's not too much of a help, but the calculator trick can be a help in some cases. Okay, let's do another one. Speedboat slows down at a rate of 5 meters per second squared, comes to a stop. If the process took 15 seconds, what's the displacement of the boat? What do we got here? Something's 5 meters per second squared. What is that? Is that velocity, initial or final? What is it? Taylor? It's acceleration. Good. I don't know if you guys notice. Sometimes I leave a little space. And usually when I do that, it's because I want to leave space for something that I purposely left out. Why is that -5? Tell me why that 5 is -5. Slowing down, right? Speeding up, make it positive. It's slowing down, make it negative. You could say the acceleration is -5 to the right if the boat is moving to the right, or you could say it's accelerating at 5 to the left. Okay, an acceleration of 5 to the left is the same thing as slowing down at 5 to the right. Okay, what else we got? 1.5 seconds is our time interval here. And that's it, I think, isn't it? Looking for the displacement. There is something else here if I read between the lines. Good. VF is 0. It says it comes to a stop. We can't just assume that something comes to a stop just because it's slowing down. But if it physically tells me it comes to a stop, then I can say easily that VF is equal to 0. Okay, A, T, D, and V. A, T, D, and V. I think I want to try this one. VI is 0, so I'm going to cross that off. VI is 0. 0 times 1.5 seconds gives me 0. One more example here, page 15. It says a bullet accelerates through the length of a barrel of a gun at 0.750 meters with a magnitude of 5.35 times 10 to the 5 meters per second squared. So listen, this is a pretty big rate of acceleration, right? But it's got to, right? If you're accelerating a bullet from 0 to a speed that can kill an animal over a distance of 3/4 of a meter, then it's got to be a high rate of acceleration. 5.35 times 10 to the 5, 535,000 meters per second squared. What's the speed at which the bullet exits the barrel? We're going to say that the length of the barrel is 0.50, or we'll make that the displacement because that's how far the bullet travels while in the barrel while it's accelerating. The acceleration itself is 5.35 times 10 to the 5. It's positive because the bullet's speeding up through the barrel of the gun. Looking for the speed of the barrel when it leaves, looking for VF. Anything else we have to read between the lines? Yeah. Good. VI is 0 because this bullet will start at rest inside the gun. This one's going to be easier, I think. VF squared is equal to VI squared plus 2AD. Solving for VF, this is a pretty easy one to rearrange if we only have VF to solve for. What do I got to do to get it by itself? Well, it's already kind of by itself, right? There's nothing attached. There's nothing not attached. So I just got to go straight to my square/square roots. Do the opposite. Square root. Becomes VF is equal to square root of VI squared plus 2AD. So we're going to say VF is equal to the square root of what? VI is 0 plus 2 times 5.35 times 10 to the 5 times 0.750. Let's try this one on the calculator. We don't need to worry about the 0. Let's just say 2 times 5.35. Remember what I said with the whole times 10 to the whatever? Don't do this. Don't do times 10, this, 5, right? Don't do that. That's not the way that people that made your calculator intended you to do it. They expected you, they intended you to say 5.35 second function EE. That's 5.35 times 10 to the 5 times 0.75. Then we square root that. We get a final velocity of 8.96 times 10 to the 2. We could say 896. 8.96 times 10 to the 2, 896 meters per second. Yep. Whenever you enter it into your calculator, it says error. Okay, come on up here for a second. Yeah, come on up. Come on to the board. Enter it into the. Okay, just enter it into the. Enter it in there. So we're saying 2 times 5.35. Yeah, no, go ahead. Sorry, I'm messing you up. Oh, that's a problem. You get five. You're saying times 10 to the, and then another exponent button there. So you're just going to go times 10 to the 5 right there. Make sense? Okay, good. Good. All right. These ones I think you're going to find a little bit easier than the last set of questions you did. Okay. Try these ones on 52.